Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on linear modeling. So what we're doing here is we're using linear functions and linear equations to model real-world situations. So you know from this topic that a relationship between x and y is linear if it can be written in the form y equals mx plus b. So here we have two variables, x and y. Variables because they change their value. M and b are constants. Remember, we know m is the gradient and b is the y-intercept. So we're looking at situations that can be modeled with an equation like this. Now, if b is equal to 0, in this case, then we have y equals something times x. In this case, we say the two variables x and y are directly proportional. So an example of this would be, say, when you work. Let's say you earn $10 an hour. So if you earn $10 an hour, if we let y equal the amount that you earn, so y will be the dollars that you earn, and then x will be the number of hours that you work. If you earn $10 per hour, then you earn 10 times the number of hours you worked. So this is an example of direct proportion when you earn $10 an hour. So let's look at an example of something that's not direct proportion. So usually if you hire like a tradesman or something, it's not direct proportion because they charge a call-out fee. So let's say you hire a plumber. And let's say that person charges a $50 call-out fee, so $50 to come out to your property and $80 per hour to actually do their work. If we let y be the amount of money that the plumber earns and x the number of hours, now we would have the amount the plumber earns is equal to $50 plus 80 times the number of hours. Because there's a constant term here, these are not directly proportional. So in this case, y, which is the amount of money earned, is not directly proportional to the number of hours. So I'll just write not DP, not directly proportional. Okay, so we're not just interested in direct proportion, we're going to look at some other examples. So please pause and copy this down if you need. So let's say a cruise charges a booking fee plus a nightly charge. If they charge $490 for 2 nights and $1,000 for 5 nights, we're going to graph the relation between cost and number of nights, and we're also going to figure out how much they would charge for 12 nights. So before we get into this, I want us to understand this is a linear relationship between two variables. So one variable here is the cost. That changes depending on how many nights you stay. So y is the cost of the cruise, and x is going to be the number of nights that we stay. So it isn't a huge deal if you switch these around, if you said x is cost and y is the number of nights. But usually x is what we call the independent variable and y the dependent variable. The number of nights you stay doesn't depend on the cost, but the cost depends on the number of nights you stay. So for all of these applications, usually it involves cost. It is just convention that cost is on the y-axis. So x and y are two variables. Now they are related linearly because each time x goes up by 1, each time you stay an extra night, then y will increase by a fixed amount. We get that from the information because it says there is a nightly charge. So you are getting charged the same amount each night. So we know that this relationship will be linear. So that means if we want to write an equation linking the cost and the number of nights, it will be cost equals something times the number of nights plus something, because any linear relationship can be written in this form. So it's just a matter of filling out the two boxes. So we want to first, to find the number that goes in this box, we want to find how much the nightly charge is. So this is the rate of change. This is saying each time we stay an additional night, how much does the cost go up by? So that is, of course, the gradient. We know the gradient goes here. So if you like, we sort of have 2 points. We have x is 2, y is 490, and we have x is 5 and y equals 1,000. So the number that goes here, we figure it out the same way we've been figuring out the gradient in all of the other lessons in this module. It is y2 minus y1 over x2 minus x1. So if you put that in your calculator, you get 170. That means this cruise is charging $170 per night. Each time you stay an additional night, you must pay an extra $170. So what goes in this second box here? Well, you know how to do that too. We've done it a million times. What we do is we take our formula y equals mx plus b and substitute everything we know. So we know that m, which is the gradient, we just figured out that that is equal to 170. So when we're putting in x and y, remember you choose one of the points. Either one doesn't matter. So I'm going to choose this top one here. So x changes to 2. So remember it's 170 times x times 2. And y is going to change to 490. So I've got the equation 490 equals 170 times 2 plus b. So 170 times 2 is equal to 340. So obviously I've now got this equation. I can just subtract 340 from both sides and I get b is 150. So that means 150 goes in this box here. So the cost of the cruise is $170 per night plus 150. So this must be the booking fee. This is the fixed cost, what you have to pay before you even stay a night, $150. So we've got this equation and it'll be really easy to graph. We only need the first quadrant of our Cartesian plane. We don't need to draw all 4 quadrants, the reason being one of the variables is cost, which cannot be negative. One of the variables is the number of nights, and you can't stay for a negative number of nights. So we're just going to look at our Cartesian plane in the first quadrant with x and y. So you know how to graph a function like this. 150 is the y-intercept. So of course, the graph will start here at 150. 150 is what you pay before you stay any nights, just above the origin there. And after 5 nights, we get to $1,000. So we can put a point there at 1,000. So then all we have to do is draw up these 2 points. And this line goes on forever. It keeps going because you can stay more than 5 nights, so we put an arrow at the end. So the equation of this line, remember, we need to put that on the line. So we've now graphed the equation. Just when you're doing applications like this that involve money, sometimes there's going to be big numbers involved. You don't need to go and measure out your Cartesian plane, go from 0 to 100, 200, all the way up to 1,000. Just do it rough like I did here. There's no point spending the time making sure the measurements are right. So we've done the first part of this. We've graphed the relation between cost, which is y, and number of nights, which is x. So the second part of this question, how much would they charge for 12 nights? Well, that's easy now that we've got our equation. X is 12. So the cost would just be y equals 170 times 12, which is the number of nights, plus 150. And you can put that on your calculator if you want, and you get $2,190. So this cruise would cost $2,190 for 12 nights. So you see, we've taken a problem here and we've turned it into a linear relation. And that's what linear modeling is. All right, thank you so much for watching this video. This has been the luckiest maths teacher in the world. Have a great day.